In AnyLogic, you can create any object that you can imagine just by using agent-based, even the ones that already exist in AnyLogic. For example, a conveyor belt. If you want to build a conveyor belt using agent-based, this model or this tutorial will show you a very simple example to create an agent-based using creative thinking in order to build what you want. This is a simplified version. You can always make it much more complicated, but the idea is to get you started. You will always be able to download the model. The description box will have the link to it. So that's it. Let's go. On this video, I want to show you how you can create a roller conveyor where you have all these parcels moving around. You have a nice animation of the conveyor, and you can stop things. And always there has to be a space between the different boxes. And when they arrive at the end, they stop for a little bit and then they continue. So when the boxes arrive at the source, they get into the queue waiting for space in the conveyor to get into the conveyor. And to get into the conveyor, they need enough space so they don't crash with the box in front of them. Okay, so let's get started with the model. The structure is pretty simple. You have a box, you have a conveyor, and in main, you have the model. So in the source, we just define a rate, like it doesn't matter. And we come with boxes. There will be a queue in which the boxes will wait for space and the hold that is initially unblocked, but only one agent can enter. And when an agent crosses this hold, it blocks the hold until I say something different. And then on the exit, the box moves into the conveyor. But the conveyor doesn't have a flow. So that means that when it gets to the exit, what I'm going to do is I'm going to move the box into a new population of boxes inside the conveyor, and I will set the XY based on the conveyor here. So the conveyor has a population of boxes, but I don't really need a flow to make the movement. So if there's more than one box in the conveyor, we will connect this box into the new box that is coming into the conveyor. So you always know what box is in front of another box. And to do that, we use this connect to that is easy to use when you have a link to agents. I'm not going to explain a link to agents, but this is what you can do. So you connect the front box to the box that is coming into the conveyor, and you disconnect it when the box leaves the conveyor. Okay, so this is it in main. There's nothing else. Okay, so let's go to the conveyor. The conveyor has a speed that you can define. It has also a definition on what is the distance between boxes. So I put 0.5 meters. And I have a position update time. So how often should the position of the boxes be updated inside the conveyor? Because they move around and everything is discrete. So every 0.1 seconds, the box will move. So I can calculate the speed in pixels per second using the scale. This is the scale. So the speed in pixels per second will be this scale in pixels per unit multiplied by the speed in meters per second. I can do the same, the distance between boxes. I can use the distance between boxes, which is in meters, and transform it into pixels. Now, I always like to use an init function, so I always know that there's something going on the startup. So what does this do? It sets the position, the width, and the height of the conveyor. I hard-coded all this, but normally you don't want to hard-code it. And that's it. Then you have move to agents and pull box that I will explain a bit later. Then you have the box. The box has a length that is following a distribution, and I calculate the length in pixels. But this time I will do something different. Since I'm doing this calculation in the conveyor, and I will show you later how this is done, I want to get the length in pixels from the point of view of the conveyor, not from the point of view of the box. Remember that the box scale doesn't necessarily match the conveyor scale. In here we have 1 meters equals 10 pixels, but in the box 1 meters equals 20 pixels. So what I'm going to do is I will return the owner scale. The owner can be main in the beginning, or it can be the conveyor later, and I will transform that to pixels based on the point of view of the conveyor or the owner. Whenever a box is in this population, the conveyor becomes the owner of this box. And if we go to the init, I do the same here. The rectangle is this figure here, that if I click it, it will toggle the stop variable, and it will change the color. Red if it's stopped, brown if it's not stopped. And here I just set up the initial X, Y, width and height of the rectangle. So you generally want to do this. In theory, you could put the values in here. I can put the same thing here, but the problem is that you may have issues either when you run a Monte Carlo, optimization, or other experiments, or even it's difficult to maintain the reproduction of the model. Which I mean by that, if you want to use the fixed seed, you may not get the same results just because you are using animation figures to make calculations. So you have to be careful with that. That's why you want to use everything like this and avoid making calculations directly using the shapes. So how do I do this little animation here? I have the conveyor, which is this called convac, which is the background of the conveyor, but also I have this little line. I will replicate this 140 times, and here I will do the opposite of what I suggested to do before, but this is just an animation gadget, and I won't use for any calculation. It's just nice to see, so it won't affect any experiment. So there's no problem with that. And I use the index. Since I'm using replications, I use the index multiplied by 5 as 5 pixels. And then I, depending on how much time has passed, I use this remainder with 5, so you get this nice animation. You can try that on your own to see the different things you can do. Now, I want to move the agents. Remember that the agents now are not in a flow. The boxes are floating around without being in a flow. So what I do here is I calculate the conveyor progress. So how much is the conveyor going to move on this time step, which is the speed in pixels per second multiplied by the position update time. So this is the amount of pixels each box will move. I will loop through all the boxes. And remember that it is important to know that this is a FIFO situation. So the box with the lower index is the first one that came into the conveyor. So it's okay, I'm doing this. But I have to be aware that this is the order in which things are in the conveyor. If I'm not sure, I have to be sure. And if the box is not stopped, I can check if there's a box in front. If there's no box in front, the box will just move this amount, the conveyor progress that I calculated before. But if there is a box in front, I need to make this calculation to see if there's distance that will make me crash or will make the box crash. and then I see how much can this box move without crashing. And then I define this new progress for the box. If the box arrives at the end of the conveyor, and this is here, I'm doing something that I told you shouldn't do. This is the things that might cause problems, because when you do random Monte Carlo, this value might not be the correct one. But I'm using it here just to make an example of something that you shouldn't do. The same with this. But anyways, since we're not doing a Monte Carlo, this will work. This means that if the box gets to the end of the conveyor, it will send a delete message to the box. So let's see what this message is. So messages are received in this connection object. So when a message is received, what I do is I stop the box and then I do this event restart after 22 seconds. This is hard-coded. Remember, you should never hard-code, but I will hard-code anyways, and this event I will delete self. When it does this delete self, it disappears, so there's no box in front of the previous box, and the conveyor can continue moving boxes. So the last thing I have to do is pull box, which means that I want to bring a new box from this queue if there's space. So I check if the queue is, there's something in the queue. I get the first box in the queue. If there's no box inside the conveyor, I just unblock the hold. But if there is a box in the conveyor, I need to check the last box. Then I have to check what is the distance that this box had to travel in order for another box to come into the conveyor. And if it traveled that distance, then I can unblock the hold. So I will bring a box as soon as there's space to bring it. And this is it. Very simple. Now you can run it and you will see how things move nicely.